Welcome back to Hardware Unboxed. Today we are checking out the most expensive Ryzen CPU you can buy, which, as you might suspect, is also the fastest, most powerful Ryzen CPU currently in existence, and the upcoming Zen 4 AM5 parts won't actually change that, at least not for core heavy workloads. For testing, we have AMD's Ryzen Threadripper Pro 5995WX, a 64-core, 128-thread workstation CPU that's actually been out for about 5 months now. Now, AMD first announced and released this monstrous CPU back in March of this year, but it was for OEMs only, and in fact, at first it was for just one OEM, being Lenovo. However, as of today, the Threadripper Pro 5000 series is going retail, and that means you can now build your own insane workstation. That is, if you have enough money, because boy oh boy are these things expensive, and I'll get to the price in a moment, but before I do, today's sponsor spot is brought to you by Be Quiet and the new FX range, which adds ARGB lighting to some of our favorite Be Quiet products. Their new Pure Base 500 FX case comes with 4 pre-installed Be Quiet Lightwings fans, complete with internal and external ARGB lighting. Then for cooling, you have the option of either air or liquid. The Pure Rock 2 FX is the Pure Rock 2 Black that we all know and love, but now with a Lightwings 120mm fan. Likewise, the Pure Loop has been upgraded to the Pure Loop 2 FX with a new and improved pump that supports PWM control, supports radiators up to 360mm, and of course up to 3 Lightwings high-speed ARGB fans. Discounts of up to $30 US can be had when you purchase any FX product between now and the end of September, so to find out more, please click the links in the video description. Okay, so these new Threadripper Pro 5000 processors, they aren't cheap. The base model 24-core 5965WX, that costs $2,400 US. Then we have the 32-core 5975WX, that comes in at $3,300. And then, of course, the 64-core monster that I'll be testing, that costs a cool $6,500 US, which locally here in Australia translates to about $11,000. So I made sure I didn't drop it. Now, I've been using the Threadripper 3970X for quite some time, as has Tim, and our video editor Balin also uses the 3990X, and all of which are quite expensive CPUs in their own right, though they are much cheaper than the Threadripper Pro 5000 models. The 3970X, for example, costs $2,000 US, so about 40% less than that of the newer model, while the 3990X, that was conveniently priced at $3,990 US. Again, about 40% less than that of the newer Zen 3 version. So, if you're wondering why the Pro models cost so much more, it's because they're legitimately more workstation oriented. For example, you get twice as many PCIe lanes from the CPU, 128 versus 64, while the current AM4 desktop parts have just 24 in total, 16 for the primary PCIe slot, 4 for the primary M.2 slot, and then 4 connecting the chipset. Another big advantage is memory support. Whereas AM4 processors support dual-channel memory and HEDT chips like the 3970X and 3990X utilize quad-channel memory, the Threadripper Pro series goes a step further by supporting octa channel memory, so 8 DDR4 memory channels just like the EPYC server processors. In fact, the 5995WX that we'll be testing is really an overclocked EPYC 7713P, though the server CPU does cost less at around $5,000, but it does clock much lower. Speaking of clock speeds, the 5995WX packs a base clock frequency of 2.7 GHz with a boost clock of 4.5 GHz. That's 22% higher than that of the EPYC equivalent. This chip consists of 8 CCDs and an I/O die, giving it 64 cores, 128 threads, and a beefy 256 MB L3 cache. The 32-core 64-thread 5975WX features 4 CCDs and an I/O die, clocks at least 3.6 GHz with the same 4.5 GHz boost. Then the 24-core 48-thread 5965WX also packs 4 CCDs and an I/O die, clocks no lower than 3.8 GHz under load, with a peak operating frequency of 4.5 GHz, and both the 24 and 32 core versions feature a 128 MB L3 cache. And finally, all 3 models support 128 PCIe 4.0 lanes, 2 TB of DDR4 3200 octa-channel memory, and a TDP of 280 watts. Now, what all of this means is AMD has officially killed off the HEDT version of Threadripper and replaced it with the workstation version, so Threadripper Pro. So I guess the question is, what's changed and why have they done this? I'd say the reason is a few things, but put simply, demand for Threadripper just didn't justify a more affordable version. Sure, it made sense back in the Zen and Zen Plus days when mainstream desktop processors topped out at 8 cores, but today's 16-core models like the Ryzen 9 5950X do a good job of satisfying the needs of most power users. Also, back in the early days of Ryzen, AMD was desperately trying to gain market share in all segments, so offering compelling products at as many price points as possible just made sense. Today though, AMD is dominating on all fronts, and with absolutely no HEDT competition from Intel, it's not a segment they need to compete in, and for most high-end users, the Ryzen 9 5950X will suffice. So while we would personally love to see more affordable Threadripper parts, from a business standpoint, it just doesn't make sense. The good news now, of course, though, being that if you can afford a workstation PC, you don't have to buy an OEM system, which, let's be honest, they're typically not that good, at least relative to what you could potentially build yourself. Now, when it comes to WRX80 motherboards, your choices are still quite limited, with well under a dozen models to pick from. And I think the boards that are most likely to appeal to our audience include the Gigabyte WRX80 SU8 IPMI, a very cool name I know, the Asus Pro WS WRX80E-Sage SE Wi-Fi, an even cooler name, the ASRock WRX80 Creator, a nice simple to the point name, I quite like it, and then we have the board that we'll be using today, the MSI WS RX80, the simplest and most to the point product name of them all. Basically, I could have had my pick of these WRX80 boards, and I went with the MSI version for a few reasons. Firstly, wasn't really that impressed with the look of the ASRock and Gigabyte boards. Those VRMs look as though they'd be okay for stock 280 watt usage, but a late change by AMD has seen Threadripper Pro 5000 support overclocking, and this means those boards will need to be refreshed if they wish to support overclocking properly, especially for parts like the 5995WX. Asus was also caught out by this late change, and their board doesn't support features such as PBO. So it would seem that taking their time has paid off for MSI, as the upcoming WRX80 board supports both auto overclocking in the form of AMD's PBO, as well as manual overclocking control, and with an 11-phase 105 amp design, it's already setting records, pushing the 5995WX to an insane 5.15 GHz for a score of 116,000 points in Cinebench R23. Though, please note that we are talking about an Allen 2 overclock here. The point being, though, that this VRM is good to handle pretty well whatever you throw at it. Having said all of that, sadly for this initial review, overclocking is completely off the table, and the reason why is a bit of an unknown. MSI says that my pre-production board was tested before being sent out, and that both PBO and manual overclocking worked. However, after several BIOS updates and endless tinkering, the OS features refuse to reveal themselves, and we just can't work out why. MSI will be providing a second board, and hopefully that allows us to overclock the 5995WX, but for now, we're stuck with the stock results, which I've got to say, they're not half bad. I've also included a configuration with the power limits removed. Now, for testing, Team Group provided 4 kits of their Team T-Force Extreme ARGB DDR4 3600 CL18 memory, giving us 256 gigabytes in total, though please note for stability the memory was limited to DDR4 3400, not 3600. And I actually didn't have 8 memory modules of the same specifications, so Team Group really did come in clutch here, making this review possible. So a big thank you to Team Group, as well as MSI for supplying the WRX80 motherboard, and of course AMD for shooting over the Threadripper Pro 5995WX CPU. Now for comparison, I've included the Threadripper 3990X, which was tested on the MSI Creator TRX40 motherboard, using the same Team T-Force DDR4 3600 memory at 3400. Then we have a few desktop CPUs for comparison, being the Ryzen 9 5950X, tested with dual-rank DDR4 3200 memory, and the Intel Core i9 12900K using DDR5 6400 memory. Finally, the graphics card used for all testing is the Gigabyte RTX 3090 Ti. Okay, let's get into the data. Starting with Cinebench R23, we see that, as expected, the 5990WX scores big with 66,403 points stock, Then with the power limits removed, the score crept up by 5% to 69,581 points. Interestingly, the 5995WX was just 6% faster than the 3990X, though this isn't terribly surprising given that the 5950X was only around 9% faster than the 3950X in this test. The single core gains are a bit more impressive. Here the 5995WX was 14% faster than the 3990X, but also 9% slower than the 5950X and almost 30% slower than the 12900K. We're also only looking at an 8% improvement in the 7-zip file manager decompression test for the 5950WX over the 3990X, but this time removing the power limits resulted in a slightly more impressive 9% performance increase. Now for code compilation work, the 5995WX doesn't appear that much faster than the 3990X, which again makes sense as the 5950X was only slightly faster than the 3950X. So for this sort of workload, the more expensive Zen 3 based Threadripper processors probably aren't worth the premium. The Corona benchmark is almost finished at the click of a button when using the 5995WX, taking just 18 seconds. Still, that meant it was 22% faster than the 3990X, despite only shaving off 4 seconds from the completion time. Another rendering benchmark is V-Ray, and here the 5995WX was 15% faster than the 3990X, so not a huge performance gain, but about what we've come to expect for this sort of workload. Premiere Pro is of particular interest to us, as this is an application that we use daily, and it's where Threadripper shines. I've got more to say about this, which we'll save for later in the video, but for now let's check out the Puget Systems benchmark results. Here the 5995WX was 28% faster than the 3990X, which is a significant performance advantage, and this translates into serious real-world improvements, which I'll discuss soon. I believe the increased memory bandwidth and improved single-core performance is largely responsible for the performance gains seen here. Now, for those of you using Photoshop, high core count CPUs, they're a bit of a waste, at least for the most part. There might be some plugins that can utilize more cores for specific tasks, but in general, this is a very lightly threaded application, and therefore higher clocked, higher IPC parts like the Core i9-12900K are just much better here. Finally, the last application benchmark is Blender Open Data, and we'll also look at power usage in this test soon. Once again, when it comes to rendering benchmarks, the 5995WX is generally only a little bit faster than the older 3990X. Here we're looking at a 7% performance increase, so really nothing to write home about. Power consumption is also similar to the 3990X, and it was interesting to see that removing the power limits for the 5995WX didn't see power consumption spiral out of control. In fact, we really saw little to no change here. It's a shame I couldn't enable PBO or do any manual overclocking, but that is something I can look forward to for future content. Okay, time for a few gaming benchmarks, just because you might also want to game on your workstation, rather than use an entirely separate system for that. The 5995WX was quite impressive in Shadow of the Tomb Raider, delivering slightly more performance than the 5950X, which we have seen in the past from Threadripper CPUs. The 3990X, for example, was faster than the 3950X in this game. The Hitman 3 results, though, they're a bit more typical. Here, the 5995WX was slightly slower than the 5950X. We're talking about a mere 3% decline in performance, which meant it was still 18% faster than the older 3990X. Rainbow Six Extraction sees similar margins to that of Hitman 3. The 5995WX was just 4% slower than the 5950X, but 10% faster than the 3990X. However, removing the power limits did allow the Threadripper 5000 Part 2 match the 5950X. The 5995WX was on par with the 5950X in Watch Dogs Legion, making it 15% faster than the 3990X, but much slower than the 12900K. We're also looking at comparable performance between the Threadripper 5995WX and Ryzen 9 5950X in Horizon Zero Dawn, meaning that the new 64-core processor is 17% faster than its predecessor. Now let's talk a bit about cooling. If you're familiar with the Threadripper 3000 processors, then the new 5000 series, it won't offer any surprises. Basically the same deal. The layout is very much the same and the power consumption is also very similar. Therefore, the cooling requirements will be much the same. Now, for our review, I used the Be Quiet Silent Loop 2 360mm all-in-one liquid cooler with the Be Quiet STRX4 mounting kit. Like most AIOs, the Silent Loop 2 isn't purpose-built for the massive Threadripper CPUs. Instead, it was designed with LJ1200, 1700, and AM4 processors in mind. So it doesn't exactly cover the entire heat spreader of the Threadripper processor, but it gets most of it. Now, I did run into an issue with our build, as the Be Quiet Darkbase Pro 900 Revision 2 case, which we use for our testing, was unable to fit the Silent Loop 2 360mm AIO in the top of the case, as the MSI WS WRX80 motherboard is just simply too massive. And as a result, we had 4 sticks of Team Group's memory exactly where the radiator needed to go. This means we were forced to front mount the radiator, which normally isn't an issue. However, the Silent Loop 2 water block is designed to only be oriented in a single direction with the Be Quiet STRX4 mounting bracket, and when using the correct orientation, the tubes for the AIO simply wouldn't reach the radiator when front mounted. So I was forced to install a block backwards in the bracket, which sees it positioned well off center on the Threadripper IHS. Therefore, I had to get the Dremel out and crudely cut a section of the Be Quiet STRX4 mounting bracket so the block would be positioned more centrally when installed backwards. Anyway, it was a bit of messing around, but we now have the block centrally located with what appears to be good mounting pressure. Of course, I did test thermal performance before we got benchmarking, and everything looked good. After an hour of looping the Cinebench R23 benchmark, we hit a peak temperature of 83 degrees, which, given the power usage, I think that's quite a good result. That said, it's unlikely to be optimal, and if we look closely at the peak core complex die temperatures, we see that only 2 peaked at around 80 degrees, then 2 more peaked in the mid to low 70s, with what I assume are 4 centrally located CCDs peaking at between just 57 and 61 degrees. So it is plausible that with a proper custom designed block, we could probably keep the peak temperature at more like 70 degrees, but that's a guess on my behalf. The Threadripper Pro 5995WX is certainly a very impressive processor, and although for the majority of our testing it wasn't really a great deal faster than the 3990X, it can be around 30% faster depending on the workload, and in our case that percentage gain is actually fairly meaningless. As I explained earlier, we're currently using the Threadripper 3970X and 3990X in our editing PCs, and while both have been completely game-changing for us, allowing us to stabilize dozens upon dozens of B-roll clips at once while also providing impressive encoding performance, the recent upgrade to Panasonic's GH6 has caused a few editing-related headaches. Now, previously the Threadripper 3000 series had no issues at all with the 4K 60 footage from the older GH5, but when we upgraded to the GH6, we wanted to start working with the 5.7K 60 FPS footage, and this became troublesome. Of course, we could use proxies, but they're really a pain for editing. Creating them takes a lot more time, and it's just a more cumbersome method than we're used to. So we'd already been actively searching for alternatives. We tested out the Core i9 1200K, and really this was quite amazing for scrubbing through timelines and general editing, but as soon as we wanted to stabilize more than about a dozen clips at once, the system became pretty well unusable and would often crash. And this meant we had to stabilize clips in batches, saving after each batch was completed before starting the next batch. It wasted a lot of our time, and the encoding process was also slower. A much better, but admittedly also much more expensive solution would be to upgrade to a Threadripper 5000 series part, and the 5975WX would probably be the best option for our needs. So the first thing we did with the 5995WX was open up a current project that we were working on and start editing, and boy oh boy was the experience totally different. At no point did the 5995WX struggle with the 5.7K footage like the 3990X did. Even color-corrected footage with transition played back smoothly. In short, the 5995WX has been a complete game changer for our workload, and as such, it's difficult to put it into the context of percentage gains. It's not just faster, it's wildly more practical. I guess you could say editing's now more playable, to use a gaming term. So I'd say we could quite easily justify spending $3,300 US on the 5975WX, plus everything else you need to build the workstation PC, as it really would pay itself off, both in terms of productivity and mental health. So it really is difficult to give something like the 5995WX a value rating. If it can do for you what it can do for us, then it's really invaluable and will without question pay for itself. It's a workstation product designed for professionals, and with no retail competition from Intel, it's really your best option. I'm also very happy that AMD is finally giving customers the chance to build their own workstation PCs and aren't forcing them to buy mediocre OEM systems. So that in itself I feel is a big win. I look forward to putting the 5995WX through its paces over the coming months and of course years, and I hope we can also take a look at the 5975WX soon, as I feel that model is probably going to be better suited to our use case. Anyway, if you enjoyed this video, please do one of those. A like, not one of what, well, we can't see those anymore, so it doesn't matter, you're just wasting your time. Also, you can subscribe for more content, and you can become a Hardware Unboxed community member. So you can do that by signing up to Floatplane or Patreon, links for those in the video description. You get access to a monthly live stream with Tim and myself, Q&As, behind the scenes content, and access to our exclusive Discord server. So a lot of cool stuff there. If you're interested, check it out, but if not, that is perfectly fine. And I would like to thank you for watching this video. I'm your host, Steve, and I'll see you again next time.